So, very good morning, students. Welcome to IIT NEET Foundation or Focus C program by Krishnaveni Talent Schools and the Mastermind Schools. So, once again, I welcome all the class 8 students, all the class 7 students for today's session. As you all can see on the screen, and you are well aware, my subject is physics. We are in class 7th. Our ongoing chapter, laws of motion, and today we are in the session number 3 or the last session. So we'll continue where we left in the last class, but before that, let us recall what we learned in the last 2 sessions. So as a part of laws of motion, before going further, we learn about what is force first, right? Examples of force, many examples, and effects of force, and types of force. After knowing about this, we started the first law of Newton. And also we have given the second law of Newton we have introduced. So these are the topics what we covered in the last 2 sessions in chapter laws of motion, third chapter. So we'll continue again where we left in the last class with the Newton's laws. As you all know that there are 3 laws are there for Newton. Newton's first law says that it is a law of inertia. Newton's second law, it is a law of momentum, where we learn about we define the momentum and all. Okay. So as we progress forward, he is a great person who is the responsible for the Newton's laws. Okay. Newton's laws. So after knowing about Newton's first law, we started discuss like a second law also, where first we discussed about what is momentum. As you all know that momentum is nothing but mass into velocity is called momentum. So the heavy body and lighter body will have different momentums. A body with great speed or less speed have different momentums. Means the momentum of a body depends only on mass and velocity. So the product of mass and velocity is called momentum. So based on this only the Newton's second law is defined. So there are so many examples also we discussed about the momentum. And see here, as per the Newton's second law, right, it states that the rate of change of momentum is directly proportional to applied force. The rate of change of momentum. Rate, what is rate? Rate is nothing but time. So change of momentum. So momentum, for example, initially the momentum is, suppose say P1 is equal to M into U. Example I am telling. And final momentum P2 is equal to M into V. Initially body have momentum of mu, it increased to mv. Then what is change in momentum? So change is nothing but m final minus initial, mv minus mu. When asked for rate of change of momentum is nothing but mv minus mu by t, time will come. So it can be m common if you take from both, right? V minus u by t. So what is v minus u by t? Rate of change of velocity, that is acceleration. So ma, that is force. So the force is directly proportional to rate of change of momentum. From that we got the very popular formula in physics. Newton's second law of motion is also called as law of momentum. Right? A simple definition, there is nothing complications. A simple way from the definition of acceleration we defined. Clear? That is Newton's second law. F is equal to ma. So as you know that force of units, before concluding about the entering the third law, units of force. So first is dyne is a CGS unit, Newton is a MKS unit, or you can measure the force in gram force. That is GF. Gram weight also you can measure. Given 1 gram force is equal to 980 dynes. So kilogram force or kilogram weight, 1 kilogram force is equal to 9.8 or 10 Newton. Very important values for the blanks. So these are the three units of the force, either dyne or Newton, or very important relation here. So 1 Newton is equal to 10 power 5 dyne. Means conversion of SI system into CJ system. Right? 1 dyne is equal to 1 Newton is equal to 10 power 5 dynes. So force can be measured either in dyne or Newton, gram force or kilogram force. KGF or GF. Right? This is completely about the Newton's second law, which is also known as law of momentum. Law of momentum. Okay. Now, all the conceptual questions you can solve directly. When you move to the Newton's third law, everybody knows it's a very famous law, Newton's third law. So first we'll discuss about third law, then we'll go for the other two topics, law of conservation of momentum and application. So as you know that Newton's third law states that for every action, there is equal and opposite reaction. So that is action is equal to minus reaction. Action is equal to minus reaction. When, for example, you take a ball, rubber ball, hit to the wall. That is action we are giving. After hitting the wall is given reaction. So ball bounce back. That is action, reaction. Suppose you are walking on the floor. Our foot is applying force on earth. Forward direction, backward direction, and we are moving forward. Reaction by the frictional force. Action, reaction. Swimming. When you are swimming also, will make the water to go backside and move forward. Chase. Action, reaction. So there are innumerable examples in our day-to-day applications where action and reaction takes place. But condition is both action and reaction should be on same body, should be on different bodies, should be on different bodies, should not be on same body. Very, very important conditions here. Conditions applied with the whenever action and reaction should be on two different bodies, then only the Newton's third law is applicable. If both are on same body, body cannot move because you know that magnitude of action and reaction are same. What happens if equal force acts on same body in opposite direction? Body cannot move. It is equilibrium. Imagine you are traveling by car, right? Your car is stopped. You and your father, mother, and your brother is there. Self is not working. What will do? Your father asks you to get down from the car and asks to push if you are heavy enough. Or they will take the help of other people to push from outside. Why can't you push from inside? Why can't you move the car by pushing from inside? Why you have to get down and push? Because when you are sitting inside the car, you and car are one body only. So action is on car only, reaction also car only. So car cannot move. But when got down from the car, you are different body, car is different body. So you can make the car to move or bus to move, whatever it may be. Yes, so condition for Newton's third law is action and reaction should be on two different bodies, not on same body. Very, very important condition where most of the people will get confused. Okay, so that is explanation given here, how force will exert on the, there are so many examples are given here, you can see, which will come across. We know everything about these examples. First one, when a sailor pushes with a pole, the bank offers an equal and opposite reaction which makes the boats to move. So he's a sailor. When he pushes the water back, he'll move forward. Next, in case of person moving forward during swimming, when a person swims, he pushes the water in backward direction with his hands, that is action. As there is a reaction, the water pushes the person in the forward direction with equal force. That is reaction. Got it or not? Third one. In jet engine, and rockets or satellites. The fuel is burnt, produces large quantity of the hard gases. You can see gas will come downward direction, rocket will move forward. Right, out of the nozzle with a great force action, and to Newton's third law of motion, the equal and opposite reaction pushes the jet, airplane or rocket forward direction with a great speed with a reaction. So when you see the launching of Mars or anything, any missions or satellites or rockets, even our Diwali rockets also. So the fire will come downward direction as action, and reaction, the rocket will go up. Clear? So all these cases, what we are seeing is one is action, other is reaction, which are on different bodies, not on same body. Correct? So many more examples are there, we'll see. You can see. When we walk on the ground, then our foot pushes the ground backward. Right, action. In return, the ground pushes our foot forward with equal and opposite force, that is reaction. So the power exerted by the ground on our foot makes us to walk forward. So because of the action, reaction only, we can able to walk on the floor. Whether action is not there, if you stand like that on floor, you cannot move. There should be some action to produce the reaction and make the body to move. Clear? There. So this is about the Newton's third law of motion. It is also called as law of action and reaction. Very famous law. So Newton's second law we have done, law of momentum. Newton's third law also we have done. Then, so correct continuation of Newton's second law we have very important statement. Law of conservation of momentum. You know, law of conservation of energy in lower class you might have learned in chemistry. Law of conservation of momentum. So conservation is there means remains constant. See, in the second law of motion, we have studied that moving bodies possess momentum y equal to product of mass and velocity. That is, momentum is equal to mass into velocity. We already seen before the second law. Now we will now take one example to understand the meaning of the term conservation of momentum. How momentum is conserved. Conserved remains same. Suppose a speeding truck, fast moving truck, hits the stationary car. A car is stopped, truck is coming and hit the car. So which the car also starts moving. Now in this collision is an accident. The velocity of the truck decreases, but velocity of the car increases. Very interesting. Suppose here one car is there. Right? It is at rest. Here one truck is coming, heavy truck. With a lot of luggage. Right? It is coming with some velocity u meter per second. It is 0. So what happened when this truck is came and hit the car will move with a great speed, it becomes v. But this velocity decreases. This car stops, truck stops, but car moves with a great speed or jumps also. That is the momentum produced. Right? Due to this, the momentum of the truck decreases and the momentum of the car increases. It has been found that increase in the collision, the momentum lost by the truck has been gained by the car. What is happening here? The truck momentum is decreasing, car momentum is increasing. They transferred to that. This is an illustrator of law of conservation of momentum. What happened here? The momentum is transferred from the fast moving truck to the car at rest. But what is happening? The total momentum is same only. The total momentum is same. But one truck momentum is decreasing, car momentum is increasing. Means it is transferred. For example, you see, you are using current, right? When switch on the fan, what happens? the current, electric current is converted into mechanical energy. Fan makes the fan to move, right? So that is the conservation of energy. What is happening here? Electrical energy is converting into mechanical energy. Suppose when you are using iron box, you are using current. Electrical energy is converting into heat energy. There is no loss of heat. Energy is not losing it. But thing is, it is converting into one to another form. You are using petrol, 1 liter petrol. So you have traveled for some distance, 30, 40 kilometers, petrol is over. It doesn't mean that petrol is wasted. What is happening here? Petrol is converting from one form to another form. Make us to travel some distance. Help us to travel some distance. That is, heat energy is converting into mechanical energy. That is called conservation. Similarly, in this case, we have seen the momentum also conserved. Momentum is conserved. Such conservation of momentum is called law of conservation of momentum. That is change in momentum. The total momentum in a system remains constant. But what is happening here? It may convert from one to another after collision, right? That is called the statement of the law of conservation of momentum, which is given by the formula m1 u1. For example, you see, so we have two spheres. One is m1, other one is m2 on same plane, right? So this is moving the velocity u1 and velocity v1. So when they are hit by force, right, they are hit. So after some distance, they are collided here. So mass, they won't change, same only, they are collided, m1, m2. After collision, so this is giving action here, this is giving reaction here. So what happened here? So m1 becomes okay, anyway. So m1 becomes v1. No, sorry, it is u2. You can take m2 u2. It becomes m1 v1. Velocity becomes v1, and m2 becomes v2. Velocity after collision. Here is the state of collision. After collision, their velocities are increasing and they are moving forward. So what is the momentum before collision? m1 u1 plus m2 u2, the total. But after collision, what happened? m1 v1 plus m2 v2. So what is the statement says that the total momentum before collision is equal to total momentum after collision. The momentum is conserved. That is called law of conservation of momentum. The total momentum before collision is m1 u1 plus m2 u2, and total momentum after collision is m1 v1 and m2 v2, because after collision both the bodies changes their velocities. Mass there won't be change. Mass remains same only, but only velocity changes, and which results that the momentum is conserved. That's what given here, the formula. Right, that is called as law of conservation of momentum. Where it is applicable, the applications. So the rockets and jet aeroplanes work on the principle of action and reaction. We will now describe the working of rocket and jet planes according to law of conservation of momentum. The chemicals inside the rockets burn and produce high velocity blast of hot gases. You can see now, gas will come downwards, hot gases. These gases pass out through the tail nozzle at the bottom of the rocket in the downward direction with a tremendous speed or velocity. You can see when the rocket is, even our Diwali cracker rocket also, with great speed the fire will come down and the rocket moves up, balance the momentum of the gases. Although the mass of gases emitted is comparatively small, but they have very high velocity. Even though mass is less, velocity is more. That is the reason momentum is more. Hence, a large momentum. An equal momentum is imparted to the rocket in the opposite direction, so that in the spite of the large mass, the rocket goes up with the great velocity. Very interesting to observe, right? So rocket launching or satellite launching, all these based on the law of conservation of momentum. Similarly, we will now describe the momentum of the conserve the bullet. Bullet is fired from the gun. Same. Barrel will come back, bullet will go forward. Initially, before a bullet fired from a gun, both bullet and the gun are at the rest. So, before bullet is fired, the initial momentum of the bullet and gun are zero. Now, when bullet is fired from gun, when the bullet has momentum given by the mass of bullet into velocity of the bullet, the bullet imparts the equal and opposite momentum to the gun called recoil velocity. Right? So, when you are firing the bullet, what happened? The barrel will come back and the bullet will move forward with the great speed and passes through the target or chases the target. As per law of conservation of momentum, mass of the bullet is equal to momentum of the bullet is equal to momentum of the gun. Right? So this is about the law of conservation of momentum. Okay. So this is about the total topic of Newton's law, what we covered so far. Okay. So Newton's first law, Newton's second law, and Newton's third law of motion. With that, after reading the third law, even also we discussed about the conservation of momentum. So first, before starting this chapter, first we discussed about force. We discussed about the force, what is force, then effect of force, then types of forces. Okay. Then enter the Newton's first law, which is called law of inertia. We discussed what is inertia, what are the types of inertias, inertia of rest, inertia of motion, and inertia of direction. Then momentum, Newton's second law. The force is directly proportional to rate of change of momentum, from which you got equation F is equal to ma. Then we entered Newton's third law. So we already seen one video on that. One more video I can show for you on this topic. Okay. Newton's third law. You can see this.
Newton's third law of motion. Newton's third law of motion states, for every action, there is an equal and opposite reaction. This third law always comes in pairs and is related to the force or push and pull upon an object. If you have two objects, one is doing the pushing and one is doing the pulling, no matter how little the objects are moving. And sometimes you can really see an action and a reaction. In Florida, at the Kennedy Space Center, scientists use rockets to launch space shuttles into orbit. When the rockets fire, the exhaust from the rocket moves downward while the rocket moves upward. Without this law of motion, the space shuttle would never have lifted off the ground, and we would never have landed on the moon. The force of action and reaction working together caused the shuttle to launch. You can't have one without the other. Want to see another example of Newton's third law? What do you notice? This time, let's slow things down and see if we can identify the action and reaction force. Did you notice that the cannon moved backward when the cannonball shot forward? That backward movement is the cannon's reaction to the action of shooting the cannonball, just like with the space shuttle. Newton also noticed that the amount of force on the first object always equaled the amount of force on the second object.
Reaction.
In other words, the forces of action and reaction are always equal. That means if a boxer punches a punching bag with 50 pounds of force, that punching bag will also hit the boxer's fist with 50 pounds of force. Ouch! If the boxer only gives 10 pounds of force with his fist gets 10 pounds of force in return. And If he gives 5 pounds of force, he'll get 5 pounds of force back. So, if the forces of action and reaction are always equal, how do you think this is going to end? Oh, maybe don't try that one at home. Now that you know about actions and reactions, think about the many reactions we
All
cause
these ways
every day. Let's talk about one last thing. Have you ever tried to move a heavy piece of furniture like a couch? And did you wonder why it takes a minute for the couch to start moving? This is because of something called static friction. When you apply horizontal force from your body, the floor is actually applying frictional force to the same object. This continues until the object starts to move, and then sliding friction happens. Sliding friction is the same sensation that you get when you rub your hands.
Right. So this is the information about the various examples of action and reaction in our day-to-day life. Right. So with this, we have done with the chapter, Newton's laws of motion. So when we meet in the next class, we'll start the new chapter, the fourth chapter, work, power, energy. Right. So until then, thank you all of you. Have a wonderful day. Thank you.